Okay, so today we're doing binomial distribution, okay, probability. So before we did binomial, we're looking for a exact number, okay? That was the formula nck times p to the k times 1 minus p to the n minus k, okay? So that was independent and exact. Now we're looking at still independent. We're looking for a range of numbers, okay? We're looking for a range. And this is a 5-step process. Okay, so I made this nice little thing for us to go through all the steps. So we're just going to start doing questions, and you can copy down this 5-step a little bit later if you wish. So the first thing we have to do is we have to figure out if we have a big enough sample size. Okay, and the way we do that, it's n times p, and they both have to be greater than or equal to 5. Okay, so for this question, Kevin Durant shoots 88% from the free throw line. What's the probability in his next 60 shots he'll make less than 54 free throws? Okay, so this case, our n is 60. That's our sample. P is going to be 88%, so 0.88. Now our 1 minus p is going to be 0.12. So here we go. So NP is 60 times 0.88. So 60 times 0.88, times 0.88 equals 52.8. 52.8, and n times 1 minus p is going to be 60 times 0.12. So 0.12 times 60 is 7.2. 7.2. And both of these are greater than 5. Greater than or equal to 5. They're greater than 5, so we can go on the next step. Okay, so our next step is find the mean. And our mean is just NP. So we already found our mean. So that's good because it is 52.8. So that step's already done. Step 3, we're calculating our standard deviation. Okay, so our standard deviation, now you could also do this. It's our mean. It's our mean times 1 minus p. So the square root of our mean, 52.8, times 0.12. Don't forget to take the square root of it. So 52 times 0.12, and take the square root of that number. So our standard deviation is about 2.5. 2.5 is our standard deviation. Now, here comes z-score again. So z-score is x minus the mean divided by our standard deviation. Now the number we're interested in this question is 54 free throws. That's going to be our x value. So we're going to go with 54 minus our mean divided by our standard deviation. So 54 minus 52.8, then divide it by 2.5. So 0.48 is our number. That's our z-score. Then we need to interpret the z-score. So we're looking for less than 0.48. So we're going to go over to our z-score table, which we should still have somewhere, and find 0.48. 0.48 is right here. 68.44. So that would mean there's a 68.44 chance he will hit in his next 60 at-bats. He'll hit less than 54 hits. Okay? Now this is helpful because if we would have done it with the exact before, we would have had to do all the probabilities for 1, 2, 3, 4, all the way up to 54 and add all those up independently, because that previous format only did one of those. But we're looking for a range using z-scores real convenient because it gives you the probability it's going to happen using the z-score. Okay, so we're going to do a couple of these questions. The big thing to look at here is we're looking for a range question, less than. Okay, looking to find your probability, your n values, but figure out what it's asking for, less than, more than, or between. So Aaron Judge in baseball is currently hitting about .400 or 40%. What's the probability in his next 10 at-bats he will get more than 6 hits? So this is where we have to do n times p. So 0.4 times, our n in this case is going to be 10. The probability is going to be 0.4 equals 4. And it would be our 1 minus p is going to be 0.6. 0.6 times 10 equals 6. But we have an issue here. That is not greater than or equal to 5. So our sample size is not big enough, so we can't go forward. Even though this one checks out, this one is not big enough, so we can't go any further, and we're done the question. All right. So same question, but I adjusted the number of hits now, of number of bats. So he's currently batting 400, so that's my probability. His next 100 at-bats, okay, what's probably he'll get more than, so we're looking more than, so we have a range, more than 43 hits. So our n times p is 100 times 0.4, which is going to be 40. Then 100 times 1 minus p, if he's hitting 40%, then the opposite of that, or the complement, is going to be 60%. So 0.6, 60. So these are both bigger than 5, so they both check out. Now our mean in this case is 40. So we're good to go there. And we need to calculate our standard deviation. I encourage you to pause the video and work ahead and then see if you get the same answer right. So it's going to be 40 times 0.6. Don't forget to take the square root of this number. There's going to be lots of people who don't. So the answer there is about 4.9. So our standard deviation is 4.9. Okay, how many hits were I looking for? 43. Oh, and more than, right? More than 43. So in this case, our x this time is 43. Our mean is 40. And our standard deviation is 4.9. So x minus the mean divided by standard deviation equals 43 minus 40 divided by 4.9. Equals divided by 4.9, 0.61. 0.61. So let's go to my z-score, find 0.61. 0.61, let's go 73% there. So 73%. Now, if you remember z-score, the z-score always tells you the number below or less than. I want more than. I want the more. So I'm going to go 100 minus 73, which is going to give me 17%. So there's a 17% chance he hits more than 43 hits in his next 100 at-bats. Now, there's one last type of question I can ask you here. We're going to work with this one. So iPhone manufacturer claimed to be 98% defect-free. if you buy 1,000 iPhones, what's the probability that we have between 990 and 950 defect-free phones? All right. So in this case, my N is 1,000. My P is 0.98. And my 1 minus P is going to be 0.02. So my NP, 100 times 0.98, I want to say is 980. Is 980. Good. Then 1,000 times 0.02 is going to be 20. So those both check out. They're both bigger than 5. And my mean is 980. So let's figure out our standard deviation. So it's the square root of our mean times our failure percentage. So 980 times 0.02, I'm going to take the square root of that number, is 4.4. Hopefully I picked good numbers here. Now this time we're looking for between two numbers. So we have to run this twice. We do a high number and a low number. So our high number is 990 minus our mean, which was 980, divided by our standard deviation. So that's going to equal 990 minus 980 divided by 4.4. It's going to be 2.27. 2.27. And that on my z-score (2.2) 98.84. Is 98.84%. Okay. Now, one second here. I said 950. I have to change my number up to make it a little bit better. Yeah, I'm going to change that number to 975. Okay. 975 minus 980. It was going to give me a ridiculously big number. So I just want to make sure I get a better representation. Divided by 4.4 is going to be, so that's 975 minus 980 divided by 4.4, negative 1.14. Oops, negative 1.14. When I go to my z-score, negative 1.14, 1.14, 12.71. 12.71. So now to find the range between them, we're just going to minus these two off. So 98.84 minus 12.71 is going to give me 86.13%. So there's an 86.13% chance that in the next batch of iPhones you get between 990 and 975 will be defect free. So just to review here, you need to figure out if it's asking for a range first, range or exact number. Okay, that'll pick the formula. That is whether it's asking for less than, then that way less than, you just take the number that it provides you with your z-score. Make sure it's over 5. If it's more than, you have to do 100 minus it. Or if I'm asking between two numbers, you have to minus off the two percentages. Okay, So once again, that is for range and independent items. That's when you do that. Okay, have a great day.